At exactly 11:47 p.m., Beijing time on December 3rd, 2024, something shifted in the global balance of power, not through military action or diplomatic negotiations, but through a single administrative announcement from China's Ministry of Commerce. Export restrictions on 5 rare earth elements effective immediately: gallium, germanium, antimony, graphite, and high-purity manganese sulfate. Materials most people have never heard of, but without which the technological civilization we take for granted cannot exist. The timing was surgical. Markets closed, Western governments preparing for holiday recess, a moment when the world's attention was elsewhere, focused on year-end politics and festive distractions. But in the server rooms of major technology companies, in the procurement departments of defense contractors, in the strategic planning offices of national governments, the implications were immediately clear. China had just demonstrated that they control the foundation of modern industrial society. The announcement was clinical, bureaucratic, wrapped in language about environmental protection and industrial upgrading. Nothing about economic warfare, nothing about geopolitical leverage, just routine regulatory adjustment to promote sustainable development and protect China's natural resources. The kind of administrative notice that gets filed away and forgotten by media outlets more interested in political drama and celebrity scandals. But the numbers tell a different story. China processes 91% of global rare earth refining. They control 95% of high-purity manganese sulfate production, essential for every electric vehicle battery. Their share of lithium processing reaches 70%, graphite purification 90%, cobalt refining 95%. These aren't market positions built through competitive advantages or natural resource endowments. These are strategic monopolies constructed systematically over 2 decades, while Western nations focused on financial engineering and service economies. The rare earth elements targeted in December's restrictions, power technologies that define modern life. Neodymium and dysprosium create the permanent magnets that enable wind turbines to generate electricity and electric motors to drive vehicles. Terbium and europium produce the phosphors that make smartphone screens visible and LED lights efficient. Yttrium enables laser systems used in everything from fiber optic communications to precision manufacturing. Remove these materials from global supply chains, and the technological infrastructure of advanced economies begins to disintegrate. But December's announcement wasn't the beginning of China's resource strategy. It was the culmination of a plan that began in the early 2000s, when Chinese leadership recognized that controlling critical materials would provide more leverage than controlling traditional commodities, like oil or agricultural products. While Western companies optimized supply chains for cost efficiency and just-in-time delivery, Chinese state enterprises systematically acquired processing capacity for materials that had no substitutes. The strategy was elegant in its simplicity. Invest heavily in processing technologies that Western companies considered low margin and environmentally challenging. Subsidize production to keep global prices low enough to discourage investment in alternative sources. Gradually consolidate market share until alternative supply chains become economically impossible to develop. Create dependencies so deep that customers have no choice but to accept whatever terms China chooses to offer. Consider the lithium supply chain that powers the electric vehicle revolution. Australia mines the most lithium ore globally, producing spodumene concentrate from hard rock deposits. Chile extracts lithium from salt flats in the Atacama Desert. But raw lithium is useless for battery production. It must be converted into lithium carbonate or lithium hydroxide through chemical processing that requires specialized facilities, technical expertise, and enormous capital investment. China built that processing capacity while Western companies focused on mining. Today, 70% of lithium conversion happens in Chinese facilities, often using ore imported from Australia and Chile. Tesla needs lithium hydroxide for their battery gigafactories. They can buy Australian ore, but they need Chinese processing to convert it into usable materials. The dependency is complete and intentional. The same pattern repeats across critical material supply chains. The Democratic Republic of Congo produces 60% of global cobalt, essential for battery cathodes. But raw cobalt requires refining into chemical compounds before it can be used in batteries. China controls 95% of cobalt refining capacity. Congo mines the ore, China processes it into battery materials. Western companies buy finished products at whatever price China chooses to charge. This isn't market economics. This is resource colonialism executed through industrial policy rather than military occupation. China imports raw materials from developing countries, adds the value through processing, then sells finished products to developed economies at premium prices. The margin capture is enormous, but the strategic value is even greater. Western governments are awakening to this reality, but their response reveals how completely they misunderstand the challenge they face. The United States announces plans to build domestic lithium processing facilities. The European Union creates strategic stockpiles of critical materials. But these initiatives miss the fundamental problem. China's advantage isn't geographic or geological, it's technological and systematic. Building a lithium processing facility requires more than capital investment. It requires process engineering knowledge developed over decades of trial and error. It requires supply chains for specialized equipment and chemical reagents. It requires environmental permits for processes that produce toxic waste streams. It requires technical workers trained in metallurgy and chemical engineering disciplines that Western universities have largely abandoned. China has all of this. Western countries have none of it. The technology transfer required to build alternative processing capacity would take 15 to 20 years under optimal conditions. But conditions aren't optimal. Chinese export restrictions on processing equipment and technology mean that building alternative capacity requires starting from fundamental research rather than adapting proven technologies. The December restrictions targeted materials where China's control is most complete and alternatives are most difficult to develop. Take graphite, the single largest component by weight in lithium-ion batteries. Natural graphite requires processing into spherical graphite, then coating and purification to create battery-grade anode materials. China controls 90% of this processing capacity. Building alternative facilities requires mastering complex chemistry, obtaining environmental permits for processes that generate toxic waste, and competing with Chinese suppliers who can sell below cost because their operations receive state subsidies. High-purity manganese sulfate presents an even starker challenge. This material is essential for manganese-rich battery chemistries that reduce dependence on cobalt and nickel. Planned projects outside China meet only 55% of projected 2035 demand. The processing requires technical expertise that exists primarily in Chinese facilities. Western companies attempting to develop alternative sources face a decade-long development timeline and billions in capital requirements, competing against Chinese producers who can adjust pricing to make alternative investments uneconomical. The defense implications are staggering. Every American F-35 fighter aircraft contains rare earth elements in its radar systems, targeting computers and communication equipment. Each Virginia-class submarine requires permanent magnets made from neodymium and dysprosium for its electric propulsion systems. Guided missiles depend on rare earth phosphors for night vision systems and precision targeting. China's export restrictions don't just affect consumer electronics and electric vehicles, they affect the technological foundation of American military superiority. But the vulnerabilities extend beyond weapon systems. Modern infrastructure depends on technologies that require Chinese-controlled materials. Wind turbines need permanent magnets made from rare earth elements. Solar panels require silver processing that China increasingly dominates. Electric vehicle charging networks depend on power electronics that use gallium arsenide semiconductors. Data centers need cooling systems and power management devices that require specific rare earth compounds. Remove Chinese supplies from these systems, and the energy transition that Western governments have promised becomes impossible to achieve. Climate commitments become empty rhetoric without access to the materials needed for renewable energy technologies. The green economy becomes a Chinese economy, with Western countries as customers for technologies built from materials they cannot access independently. This dependency was constructed deliberately, while Western policymakers debated climate goals and technology strategies. Chinese leadership understood that controlling critical materials would provide more leverage than controlling oil or gas. Petroleum can be substituted, alternative sources can be developed, strategic reserves can provide temporary independence. Critical minerals have no substitutes, alternative sources take decades to develop, and strategic reserves are useless without processing capacity. The intelligence community has been tracking China's resource strategy for years, but their warnings were ignored by political leaders focused on quarterly earnings and electoral cycles. Classified assessments documented systematic Chinese acquisition of processing technologies, subsidization of production capacity, and coordination with resource-producing countries. But these assessments competed for attention with more immediate crises and more visible threats. Now the warnings are becoming reality. Chinese export restrictions are just the beginning of a campaign to leverage resource control into geopolitical influence. Countries that support American foreign policy find their access to critical materials restricted through regulatory delays and quality control requirements. Nations that align with Chinese interests receive preferential pricing and guaranteed supply contracts. This isn't economic competition. This is economic warfare disguised as industrial policy. China is using resource dependencies to fracture Western alliances and force individual countries to choose between geopolitical alignment and economic access. European nations face pressure to limit participation in American technology initiatives if they want continued access to battery materials. Asian allies must balance security relationships with America against trade relationships with China. The vulnerabilities are multiplying faster than Western governments can address them. Each month brings new restrictions, new dependencies, new pressure points that China can exploit. Antimony exports face licensing requirements that delay shipments to American defense contractors. Gallium supplies to semiconductor manufacturers encounter quality control reviews that create production bottlenecks. Graphite deliveries to battery producers face environmental assessments that introduce delivery uncertainties. These aren't random bureaucratic delays. They're coordinated pressure campaigns designed to demonstrate Chinese control over supply chains that Western companies assumed were reliable and diversified. The message is clear. Technological civilization runs on Chinese materials processed in Chinese facilities under Chinese control. Global supply chains aren't global. They're Chinese networks that other countries are permitted to access under terms that China defines. The response from Western governments reveals how unprepared they are for resource-based economic warfare. Emergency funding for domestic mining projects, trade missions to alternative supplier countries, diplomatic initiatives to secure bilateral supply agreements. These measures address symptoms while ignoring the underlying disease. China's advantage isn't in mining, it's in processing. And processing capacity cannot be built quickly or cheaply. The timeline for developing alternative supply chains extends beyond any political administration's planning horizon. Current rare earth processing projects in North America and Europe face development timelines of 8 to 12 years. Lithium processing facilities require 5 to 7 years from groundbreaking to production. Graphite purification plants need specialized permits that typically take 3 to 4 years to obtain. China spent 20 years building their processing dominance, while Western countries outsourced these capabilities to focus on higher value activities. Reversing this dependency requires sustained investment and political commitment that spans multiple electoral cycles. But democratic political systems struggle to maintain consistent policies across changes in government leadership. Meanwhile, China continues expanding their resource control. New investments in African lithium mines, technology transfer agreements with Latin American cobalt producers, joint ventures with Southeast Asian rare earth processors. Each month brings new announcements that deepen global dependence on Chinese supply chains. The December export restrictions were just the opening move in a longer campaign. China is testing Western responses, measuring economic impact, calibrating pressure to maximize leverage without triggering responses that might accelerate alternative supply chain development. The restrictions can be adjusted, tightened, or expanded based on geopolitical developments and strategic priorities. This creates a new form of deterrence. Western governments must consider Chinese resource control when making foreign policy decisions. Military interventions that anger Beijing might face critical material shortages. Trade policies that disadvantage Chinese companies could trigger supply disruptions that cascade through entire industries. Diplomatic initiatives that challenge Chinese interests risk technological isolation. The transformation of critical materials into geopolitical weapons represents a fundamental shift in international relations. Traditional economic leverage required control over large markets or essential commodities. Resource weapon requires control over materials that have no substitutes and cannot be quickly replaced. The leverage is asymmetric, concentrated, and extremely difficult to counter. Western technological civilization has become dependent on materials controlled by a strategic rival that uses this control as a foreign policy tool. The dependencies run so deep through industrial supply chains that addressing them requires rebuilding entire technological ecosystems. This isn't just an economic challenge. It's an existential question about whether Western societies can maintain technological independence while remaining integrated into global supply chains. The answer will determine whether the next century belongs to open societies with market economies or closed systems with state-directed resource control. China's critical mineral strategy isn't just about batteries and semiconductors. It's about the future of technological civilization and who controls the materials that make modern life possible. The lights still work, the smartphones still function, the electric vehicles still drive, but the foundation supporting this technological infrastructure now rests on materials controlled by a country that views resource dependency as a strategic advantage in long-term geopolitical competition. The December restrictions were a demonstration, not a crisis. The real test will come when these dependencies are leveraged during genuine geopolitical confrontations, when access to critical materials becomes contingent on foreign policy alignment, when technological civilization itself becomes a bargaining chip in international negotiations. That moment is approaching faster than most Western leaders realize. The resource weapons are already deployed. The dependencies are already established. The only question remaining is when China will choose to use this leverage and how Western societies will respond when their technological foundation is held hostage to geopolitical demands. The critical minerals crisis isn't coming, it's here, hidden beneath supply chain complexity and bureaucratic announcements, but fundamentally reshaping the balance of global power. The age of resource abundance is ending. The era of strategic scarcity has begun.